Okay. Explain how the concentration working of a buffer solution relies on the reversible reaction voltage. So the reversible reaction is Hg plus H2O goes to Z minus plus H3O plus.
Yeah.
And okay, so let's see what happens.
Plus
Suppose you add an acid. An acid is H plus. Now, the moment you
Yes.
add an acid, the acid will react with the Z minus because there's a lot more Z minus than there is any other thing. Okay, this is HCO plus. Okay, so Z minus plus H plus, and this will produce Hg.
And
ठीक है, Hg produce होगा तो इसका मतलब है कि reaction उस तरफ जाएगा and that will reduce the amount of H. ठीक है, that will just remove all the H plus.
yes.
So equilibrium shifts to the left.
Yes, so equilibrium shifts to the left. Similarly, अगर तुम base add करो, ठीक है, that's an OH minus. The OH minus reacts with the G, ठीक है, Hg ज़्यादा quantity में है. You again get Z minus, ठीक है, and that means equilibrium goes to the left, goes to the right. Let's move on. Calculate the pH of a 0.5 mole per dm cube propanoic acid. Yeah, propanoic acid 0.5 mole per dm cube है. इसका मतलब है CH3 CH2 COO H CH3 CH2 COO minus plus H plus. ठीक है. So you get that the Ka, which is 1.34 to the minus 5, the Ka is equal to CH3COO minus H plus over CH3CH2 COH. Now note that अगर ये X formed होता है और ये तो ये भी X formed होगा क्योंकि ये equal moles में है. You get X square over 0.5. ठीक है. This is in such large excess कि कोई फर्क नहीं पड़ता, and that turns out to be 1.34 times 10 to the minus 5.
Don't do that.
Yeah, but the
Don't do
idea,
this.
but what Swale was saying basically वही के propanoic acid admittedly normally you might think कि at equilibrium उसकी concentration कम होनी चाहिए, but because it
But
इतना कम वो होता है क्या कहते हैं ionized
the
whatever
dissociation is so little
Yeah.
that it doesn't really affect the concentration.
basically.
So the acid still stays about 0.5 moles per dm cube. After that, you can solve for X. X is the concentration of H plus. And then you convert that to pH by doing minus log base 10 of that.
H plus की क्या concentration आ रही है?
ऐसे
1.34
1.34 times 10 to the minus 5 multiplied by 0.45.
0.5, then you have to root it. I think 2.6 into 10 to the power minus 3.
Okay.
So you get 0.0025 0.002588.
And then do minus log base 10 of that to get your pH.
Do minus log base 10, so
Yes.
log
10.
you get 5.95. So
Nice.
minus.
Don't you get 2.6?
This is not me. This is the calculator. I don't know.
Wait. मैंने भी गलत शायद गलत डाल दिया होगा टेंशन नहीं.
पता नहीं हो सकता मैंने गलत किया हो, पता नहीं मैंने calculator में डाला था.
Should be acidic, but
दोनों के आंसर acidic है.
this is very little acidic.
Let me do this again. Maybe I might have done it. Put something wrong. 1.34 times 10 to the minus 5 multiplied by 0. So you multiply this by 0.5.
Yeah, Swale 2.6 ही आ रहा है pH.
And you do square root. पता नहीं यार मैं हो सकता गलत कर रहा हूँ.
तुम्हारा कैलकुलेटर क्या
मैंने देखो कुछ भी नहीं किया. मैंने
No,
वही डाला.
syntax might be having an issue in your that thing. Sorry. So let's not.
अब सही आ रहा है. 3.3510 पर minus 6. तुम्हारा भी याद है ऐसा?
I don't think so. नहीं मार्किंग स्कीम से उठा लो. लाइक उसको मेथड हमारा सही है, हमारे बस वो कैलकुलेशन ट्रिक्स आर वेरी बैड. अब उसमें हम कुछ नहीं कर सकते.
I am still angry at the calculator. यार कैलकुलेटर भी धोखा दे रहा. चलो इसने काम करना बंद कर दिया. चलो खैर.
Just check for
क्या आंसर आता है?
Yeah, मेरा तो
It
2.
is 2.6.
Yes, exactly. Okay, so from now on, either we do not calculate or either I just calculate using the scientific calculator. Chilling है like.
Yes, use the scientific.
Buffer solution F was prepared with 0.3 moles of sodium hydroxide.
And
so you add that to 100 centimeter cube of 0.5 mole per dm cube propanoic acid. Yeah. So sodium hydroxide or propanoic acid, you get NaOH plus propanoic acid at CH3, CH2, COOH. What do you get? CH3. plus H2O. Concentration of 0.3 moles hydroxide and sodium hydroxide किधर है? 0.3 moles इसके हैं, ठीक है?
0.03.
0.03 and 100 centimeter cube of 0.5 moles में 0.05 moles इसके होंगे, ठीक है? So if when they react, this thing will be an excess, ठीक है? तो इसके 0.03 moles form होंगे, ठीक है? और इसके 0.02 moles बच
That
जाएंगे.
is left over.
तो 0.02 left over, ठीक है? 0.03 react कर जाएंगे and left. ठीक है? तो बफर सॉल्यूशन में 0.02 मोल इसके बचे हुए हैं, 0.03 इसके पड़े हुए हैं, ठीक है?
अच्छा, वैसे तुमने थोड़ा सा आई थिंक कंसंट्रेशन ऑफ प्रोपेनोइक एसिड इज 0.5. अच्छा नहीं सॉरी 100 सेंटीमीटर की. माय बैड. Yes.
Yet calculate the concentration. So the concentration will be moles over. Where is the concentration? Yeah, that will be moles over 100 centimeter cube. So this will be 0.2, and this will be 0.3.
Yep.
Okay. So the pH equals pK plus the log of salt over acid.
Yep.
Yes.
And now SN, do your magic with the calculator. You have the K.
That's what she said. Oh God. pKa क्या है? Where's pKa?
pKa निकालना है.
Oh, pKa निकालना है.
You have Ka, right?
नहीं, pH निकालना है. What is pKa? pKa ऊपर दिया है.
We have Ka, right? So pKa निकालना है. You have to do minus log base 10 of K.
Yeah. So what's K though? I can't see it in this slide. ऊपर है.
It's 1.34 into 10 to the minus 5. But here the pH is 5.05.
Yeah, so just basically put it into the equation. Yeah, 5.05 ही आ रही है मेरी value.
ठीक है.
Can we just check that?
चलो next.
Martin sir.
I was getting the same answer. So it's,
Yep, so yeah.
yeah,
Fine.
and it's fine if you don't do all the calculations as long as people get how to solve the question. Okay, sorry, we get it.
Yes,
You get it.
calm down.
Shoulders back,
Phenyl
homie.
propanoid cannot be made from propanoic acid. ठीक है जी. And phenol. Okay. There's the
Just,
following intermediate G blah 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 and byproduct.
Before we move on, the reason why it can't be made from propanoic acid and phenol is because phenol is not an alcohol. OH group लगा होता है, but both of them are then acidic. So वो फिर वो होता नहीं है. That's the logic.
Chemistry नहीं बनती.
You could say so.
yes. Anyway.
अच्छा. Okay, so we start to go here from reverse. Okay, so that's the reverse जाएंगे. So what should G be? G should be this. O and A लगा हुआ है. So
वहाँ पे ONA है, so you want
and O8. No.
acyl chloride.
Yeah, I guess you want to Cl.
I mean, because acid से कोई change तो आया ना, like so.
And so this should be, so G should be,
Right, and then this should just be double displacement.
and there should be like, how do you make this? You add HCl. No, you add PCl3.
Yeah.
Yeah, PCl. Sorry,
SOCl2, your choice.
I think it's PCl5 is the most.
PCl5 है?
PCl3 होता है. PCl3 चलता होता है.
PCl5 भी चलता है. I mean, like they're both. ज़्यादा मैं.
चलो फिर PCl5 भी चलता है यार, ये लो यार, मुझे तीसरा.
Or you could do SOCl2 as well.
Yeah,
ये भी चलता है.
ये भी चलता है.
अच्छा, ये इधर से रिएक्ट करेगा, Na बच जाएगा, NaCl बच जाएगा.
Yeah.
Because ये वाला Na और ये वाला Cl को हमने kick out कर दिया था, तो ये J में आ गया.
Yeah, and the reason why we're going from the acid to the acyl group is because of increase in reactivity.
The acyl chloride is more reactive.
Basically.
Explain what is meant by the term bond energy. That's the amount of energy you need to break the bond.
Basically.
Yes. Is it to break the bond or is it energy used to make the bond? Not sure.
Yeah, the energy absorbed to break the bond or energy.
One mole. The energy when 1 mole of bonds is broken in gas phase. So one to break bonds.
Break 1 mole of bonds.
1 mole.
Yeah.
Molecules in
Yes.
gas. This is essential. This
1 mole.
is essential. Yes. And this is. Describe and explain the trend in bond energies of CX. From X is F, Cl, Br, or I. So CF is the strongest bond and Ci is the weakest bond, I guess.
So bond energies tend to be less endothermic as you go down the group.
Yeah, as you go down the group, as radii increases, bond length increases. So
as
it
you
becomes
go down
weaker,
the group,
so bond energy is less endothermic.
CX की bond length increases.
Basically, लंबा करते तो weak हो जाता है, so टूट जाता है. मतलब
तो bond energy decreases.
Yeah.
Describe the relationship between the reactivity of halogen alkanes and the bond energies of the. So the weaker the CX bond, so the weaker the CX bond, that means the more reactive the CX RX is. ठीक है, क्योंकि जितना आसानी से बॉन्ड टूटेगा उतनी आसानी से रिएक्शन होगा. ठीक है. So as this goes weaker, this goes stronger. Reactivity goes in. Here's the data booklet to suggest an explanation as to why CFCs such as CF2Cl2 are much more harmful to the ozone layer. And the idea here is you have to quote the bond energy of CF and Cl. Yeah. Now can somebody do the honors of finding the bond?
Wait. I think I have one open. No, I don't have one open.
Let's find the bond energy of CF. CF, 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 किधर गया?
See,
CCl ये रहा, CCl 340 है, CF किधर है? लो जी, CF को bond energy नहीं है.
are you
So it
sure?
used to probably be in the old thing. Don't see it.
Are you sure CF की नहीं है?
Not like मुझे
नहीं,
नजर नहीं आ रही. CH है, CL है, BR है, I है. If there are 3 are here, that means F should be here as well, right? And इसके नीचे bond energies नहीं होती.
नहीं और तो कहीं नहीं है.
This is the newer one, newer. So this is an older paper, I guess. But I'll look up the bond energy anyway.
फ्लोरीन की 9 देवी होती है वैसे. I don't think you have to quote the values, by the way. We just have to tell them the trend.
No, I think you have to quote the values. That's why they say use the data booklet. So let's find a value of the bond.
Bond energy को let's call it A. आगे बढ़ो.
नहीं मिल जाएगा भाई. बस इधर ही है कहीं एक से. बस अब ये देखो CF किधर है. ये 485. ठीक है. इसकी बॉन्ड एनर्जी 485 है. इसकी बॉन्ड एनर्जी कितनी है? 340 है. इसकी बॉन्ड एनर्जी कम है. ठीक है. So this is easier to react. That means this forms more radicals than this forms. ठीक है. That means this is more dangerous. CF2 Cl2 dissociates easily. So it forms more radicals.
And radicals act as क्या?
The radicals are the catalysts to the reaction, ठीक है, of this decomposing in the ozone layer.
Yeah. So O3 to O2 जाने में.
Similarly, CH की bond energy भी quote करनी होगी because it's talking about that as well. So let's find CH की क्या है.
Data booklet से देख लो.
Let's see.
It
410.
Oh.
So this is 410. Because this is the least bond energy. So CCl bond is the weakest basically. Predict the following reactions and draw their structures. Let's see. आजे भाई कौन organic के pro हैं आजे.
H2O से हमने वो डाला.
Okay, H2O reacts with this thing, I guess.
Yeah, so
दोनों साइड से Cl हट गया है. No, I think दोनों साइड से Cl नहीं हटेगा. इधर तो नहीं हटेगा.
the molecular formula of each product is given where X is here.
This was here.
Yeah, and you can tell it's forming a your carboxylic acid because उधर दो O हैं. तो like you know for a fact कि उधर वाला Cl तो निकला है. जो side
एक
वाला.
Cl तो निकलना ही था ना. एक Cl तो because some reaction has to occur.
Yeah, and yeah. So yes.
Again, Cl नहीं कटेगा because Cl की bond energy is more than I, ठीक है, and one of them is still remaining, so this has to I has to go get kicked out. You get OH. You get this.
अच्छा वैसे सवाल है, just to stop you for a second. So in the first reaction, can you explain a bit why we picked this Cl? Is it because the carbon has two highly electronegative groups attached?
No, this is because this. Yeah. Go on.
So if I'm right, the reason why we picked this Cl to displace, not the other, was because the bond will be easy. Well, on a comparative, it'll be easier to break because the carbon which is attached to has two electronegative groups already attached to it. So oxygen भी है, वो उधर से खींच रहा है, Cl भी है जो उधर से खींच रहा है, hence इसका bond आसानी से टूट जाएगा as compared to the other Cl.
Right, let's move on. Yeah, this thing is going nowhere. Let's make a beautiful. Yeah. Okay, so H2O है, ठीक है. H2O will probably again react with the Br क्योंकि again CBr की bond energy is weak as compared to with CBr. Yeah, CBr की bond energy is much weaker. ठीक है, so CBr goes away. This Br doesn't break, I think, and you get OH.
But like उधर भी CBr ही तो लगा हुआ है, like with the benzene ring.
नहीं, लेकिन this is again pulled strongly, I think. Wait, so then that means this. Okay, I think this Br is easier to go. I remember correctly, CCl का reaction नहीं होता, CBr को भी नहीं होता.
यार जाता मुझे याद है वैसे सवाल है SN2 reactions with the क्या कहते हैं with the benzene ring तो मुश्किल से होते हैं but normally शायद हो भी जाए तो like you may be able to substitute Br normally but with the benzene ring SN2 reactions generally don't happen.
Yeah, I don't think this Br goes. I'm pretty sure. Let's check bond energies. Huh? When you don't know anything, check bond energies.
But dono are carbon and Br, so like.
Let's check CH and CBr constituting. CBr is 280. CH is 410.
But which Br goes though? That's the question.
CO क्या है? CO is 360. ठीक है. So CO bond is stronger than CBr bond. That means CBr, लेकिन CBr तो जाएगा. अब उसमें से कौन सा वाला जाएगा? We have to decide. I think again इधर electronegative group ज़्यादा है. So I think there's a greater chance of losing stuff there.
Yeah, I think well we have to check for the marking scheme, but I think the logic is simple. At the end of the day, इधर क्या हो रहा है आपका OH लग रहा है ना, तो it's still in your SN reaction, and SN reactions are more happen easier with the alkyl chain rather than with the benzene ring, because with benzene ring Br की lone pair availability and all of that is come.
So you're saying इधर OH लगा दूं और इधर Br लगा दूं या इधर हटा दूं?
बेंजीन के साथ Br ही छोड़ो and दूसरे के साथ OH.
That's what I think is right. That's what I think. Yeah. Let's check the marking scheme.
Yeah. ये रही नीचे D हाँ बस.
Cl CH2 Cl CH2 CH2 COH. Yep, you have it right.
And the logic for the third reaction is again just look at tendencies of SN reactions and how SN reactions are difficult क्या कहते हैं to happen when the nucleophile is directly attached to the benzene ring. That's it.
Okay. Ethane reacts with chlorine according to the following equation. State the conditions needed for this reaction. C2H6.
Conditions.
Let's Cl2. Oh shit.
Conditions. UV though, no? It's a free radical, right? It's just free radical. UV light and free radical substitution. Let's pick up the speed a bit. I think Imad to so gaya.
One of the reaction data booklet calculated delta H. ठीक है, यहाँ पे delta H क्या हो रहा है? Cl एक लग रहा है इधर से, हाँ इधर से एक निकल रहा है और इधर से एक Cl लग रहा है. ठीक है.
Yeah, so just calculate the differences. ना तो right side पे क्या हो रहा है? Right side पे you are एक
breaking.
हाँ मतलब
so you are breaking a CH bond. So CH bond की you're breaking a CH bond.
सही है.
And you're making a Cl bond, right? Again, bond energy is for breaking, so you're breaking a CH bond and you're making a CCl bond.
You're making an HCl bond rather.
Oh yeah. Sorry.
So you just break the CH bond and you make the HCl bond. And yeah, just skip this. Like you pick the bond energies from the data booklet and input it into the equation that we've made. That's.
Let's check. Have it right anyway. So this is CH minus HCl. CH minus HCl. So we track there. Use the data booklet to calculate the enthalpy change of similar reaction.
Now
this is again the same thing. Okay, CH minus बस अब HI कर लो.
सही है.
Suggest why it is not possible to make iodine by reacting together iodine and ethane. ठीक है. This is and let's check the values. 821 minus 21.
दूसरा plus
So this is plus 111. ठीक है, तो this is endo.
and like you know it needs like 100
lots of energy.
yeah 100,000 joules per mole से ज़्यादा energy it needs
so
that
this
for it to happen
it requires too much energy. ठीक है, energetically unfeasible है.
Yeah, you could say that.
ठीक है, this is how you please the examiners. ठीक है, delta H was requires energy. Yeah.
Oh,
Anyway,
examiners is like तुम delta H positive लिख लो मैं खुश हो जाऊंगा.
Complete the following equation for some possible steps.
Yeah, ये तो पूरा है. Free radical बन जाएगा. This is your if you remember your initiation step.
ठीक है, CH3 CH2. You probably do which one CH2? This reacts with Cl minus.
नहीं तब तो फिर ये तो फिर termination step हो जाएगा. सवाल है we'll react this with the new क्या कहते हैं with Cl2 ताकि it forms another radical. सही है. So इधर एक Cl लग गया and then it forms another Cl radical, which is why the process keeps going. And for the last step we just need termination. So we need a Cl radical and we need जो ऊपर जो radical था ताकि उसी हिसाब से वो terminate हो जाए.